All right, so this is going to be the double angle, power reducing, and the half angle. So using these formulas, they kind of all go together. So what goes around comes around. No, we are not referring to the flu. We are considering different ways to write identities that lead to brand new identities, each useful in their own ways. So we've talked about the double angle identity, and now we can take the double angle identity to look at the power reducing formulas. So that's what I want you to take for a second. Take a minute and do this first problem for me. So it says double angle formula for cosine can be used to derive the power reducing formulas. So here I want to take this cosine of my double angle is equal to 1 minus 2 sine squared of theta. I want to solve this for sine squared of theta. So take a second and do that for me. Okay, so when you did that, hopefully you wrote the 2 sine squared, you made it positive. So let's move the 2 sine squared theta to the one side, and then that's plus a cosine of your double angle, and so it's going to just be equal to a 1. And then what? You move your cosine of your double angle to the other side, so you'll have 2 sine squared theta. It's going to be equal to 1 minus cosine of your double angle. Divide both sides by 2, so you're going to end up with sine squared theta is going to be equal to 1 minus cosine of your double angle divided by 2. So this is now your power reducing formula for sine. So sometimes in calculus we like to go from a squared, so sometimes they ask you to go from something that is squared down to something that does not have a square term in it. Okay. All right, so we just took something and made something else, right? All right, so now the power reducing formula can also be used to find your half angle formulas. So your half angle formulas are used when you replace your theta with alpha over 2. Okay, so let's take what we just found right here and find sine of alpha over 2. So I'm going to take this, what we just isolated right here. I'm going to plug an alpha over 2 in for each one of those thetas. Okay, so that means that I'm going to have sine squared instead of a theta. I'm going to have alpha over 2 is now going to be equal to 1 minus cosine of 2 theta, but it's 2 times alpha over 2. And then this is all over a 2. All right. Well, how do we get rid of the squared? Before we do that, let's simplify. I don't like what's inside that parentheses that I wrote over there with cosine. So this is going to be what? 1 minus cosine of alpha over 2. All right, so how do I get rid of that square? What could I do to both sides here? I can take the square root, so perfecto. So I could take the square root. So I'll end up with sine of alpha over 2. And then when you take the square root, when you're solving for a square, remember you get a plus and a what? Minus. And this is going to be 1 minus cosine of alpha all over 2. Okay. So now this, we took the power reducing formula and we made this a half angle formula. So if I'm looking for the half of an angle. So what does that mean? Like, what does the half angle formula mean? So in which quadrant? So take a second and try to answer number 2, 3, and 4 for me. So in which quadrant will 112.5 degrees lie? Will sine of 112.5 degrees be positive or negative, and how do you know? So take a second and answer these number 2, 3, and 4 for me. Okay, so where is quadrant? What quadrant is 112.5 degrees in? So that is in quadrant 2, right? And so will sine, so will it be positive or negative? So sine of 112.5, will it be positive or negative? And how do I know that it's going to be positive. So it's going to be positive because sine, right, sine of some angle is positive in quadrant 2, right? So whatever the angle is, sine of that angle is going to be positive in there. Okay, so what about this one? So if alpha over 2 is equal to 112.5, what is alpha? So what would I do to find out what alpha was? What would I do to both sides? I would multiply by 2. So if I multiply by 2, I'll get that alpha is going to be 225 degrees. Yeah? Okay, so if I want to use my formula here, so my alpha over 2, so if I want to use that information, if I want to evaluate sine of 112.5, I don't know that without using my calculator, right? So I don't know that value, but I do know that sine of 112.5 is going to be the same thing as sine of 225 divided by 2, right? Because 225 divided by 2, just like what we did right here, so 225 divided by 2 does give me that 112. So I can use, right? So I can use my half angle formula for this. And I know that sine is going to be positive in quadrant 2. So I'm going to choose the positive value outside of that square root. So I will not choose the negative, I will choose the positive. Okay, so I will say that sine of 225 divided by 2 is the same thing as sine of 112.5. So I'll say plus, and it'll be the square root of 1 minus cosine of that angle, 225, and I know what that is because it's on my unit circle, right? Divided by 2. So the reason that you're doing all these is because you're not always going to have your calculator. And so I can't find this value without a calculator, and or I need to know something that's on my unit circle to help me out. Okay. So then this will be what? 1 minus cosine of 225 is going to be a negative square roots of 2 over 2. And this is all over a 2. And then now it just takes some algebra to simplify. So it's going to be so that's what 1 plus square roots of 2 over 2 divided by 2. So if I multiply by 2 here, so I'm going to have what? So this is 2 over 2 plus square roots of 2 over 2. And this is all over a 2. And then this denominator will get down to my big denominator. So then I'll bring 2. So this turns into a 4. So it'll be 2 plus square roots of 2 all over a 4. And then I can split this up, remember, so I can take the square root of 4, which is just a 2, and then this still all will be underneath the square roots of 2, and it looks really weird like that. Okay. Alrighty, so let's look on the back page. So the back page here are your formulas. So we've got our double angle formulas that we did the other day. So these are all the arrangements of our double angle formulas. And then our power reducing formulas. So we know that our power reducing formulas, we could look for sine squared. So that means if we have a square and we don't want a power in there anywhere. So sine squared of theta is going to be 1 minus cosine of the double angle over 2. And cosine squared theta is going to be 1 plus. So the only difference right here with these two is that one's a negative and one is a positive. Okay, so what is happening? So power reducing means that I'm going from a square, right? So I'm going to a square to no square, right? But what do you notice inside of here? So what happens with our thetas? So what happens with our thetas here? So our theta is going to double. So our theta is going to double. So that's super duper important there. Okay. Okay. All right, so then we can take our power reducing formulas and they can give us our half angle formulas. Okay, so our half angle formulas are crazy looking. So they're the same ones except for things change right here. So alpha over 2, so now I'm not a double angle anymore, I'm half of that. Okay. Okay. All right, so another super important thing here is the sign that you choose outside of here. So the sign comes from the quadrant. So comes from quadrant of alpha over 2. Okay, so it comes from the quadrant of your alpha over 2. So where does your alpha over 2 lie? And is sine positive or negative in that quadrant? Or is cosine positive and negative in that quadrant? Or is tangent positive or negative in that quadrant? So that's super duper important. Okay. All right. And so that was kind of my warnings here, is that the positive and negative comes from your sine of your quadrant. So from your quadrant of your alpha over 2. And then here that we go from theta to 2 theta here. Okay. So now I want you to take a second and see if you can answer these 3 questions. So I want you to pause the video and I really want you to work on this by yourself. Okay. And see how you do. So take a minute and try to pause it and work on. Okay, so this one I do not want powers on my trig function. Okay, and I want my powers to be less than 1 basically. Okay, so this is cosine 2x, so I'm going to use the power reducing formula here. So I'm going to end up with 4 times 1 plus cosine of 2x all over 2. So that simplifies, so that's going to be 2 times 1 plus cosine of 2x. And then we could go one more step and say 2 plus 2 cosine of 2x, like that. Okay. All right, so for number 2, it says find the exact value of the expression. So cosine of 22.5 degrees. No idea where 22.5 is on my unit circle, right? But where does 22.5 degrees lie? So 22.5 degrees is in quadrant 1. And cosine is positive in quadrant 1. So 22.5 does seem like it's a half angle of something. And what is that something? So 22.5 times 2 gives me what? 45 degrees? Okay. So cosine of 22.5 degrees is going to be the same thing as cosine of 45 divided by 2. Okay. Cosine is positive in quadrant 1, so this will be a positive. And then this will be 1 plus cosine of 45 degrees, because that's my alpha. And this is all over a 2. So cosine of 45 is square root of 2 over a 2. Very similar to what was happening a minute ago. So if we multiply everything by 2, so this will be 2 plus square root of 2 all over a 4. So this will be square roots of 2 plus square roots of 2 all over a 2. All right, what about tangent? So tangent of 3 pi over 8. So 3 pi over 8 is in quadrant 1, and tangent then is positive in quadrant 1. Okay. Well, how do I find out what my alpha is? So I'm going to say 3 pi over 8 times 2. So that's what? 6 pi over 8. So 6 pi over 8. Which is the same thing as what? 3 pi's over 4's, and that is on my unit circle, right? Okay. So this is going to be the same thing as tangent of 3 pi over 4 divided by 2. All right, so tangent. So tangent's positive, so I'm going to choose the positive sign. Okay. If I wanted to use this one, so this one's very interesting, is that all of these 3 are congruent. So all 3 of these things are congruent. And it doesn't matter which one you use, and they're all going to look a little different. So we could just use the non-square root version. So if you wanted to just remember this one, that's okay. And if you just wanted to remember the sine alpha over 1 plus cosine of alpha, that's okay as well. Or if you wanted to remember the square root one. So they're all going to look a little different. So your answers may be different here, because you may have chosen one of those. So it doesn't matter which one you chose. So just choose whichever one you feel comfortable with remembering. Okay, so I'm going to use the second one. So I'm going to say 1 minus cosine of 3 pi over 4. And then this is all over sine of 3 pi over 4. Okay, so this will be 1 minus cosine of 3 pi over 4. So cosine of 3 pi over 4 is what? A negative square root of 2 over 2. So that'll turn into a positive. Sine of 3 pi over 4 is going to be a positive square root of 2 over 2. So if I multiply, this all becomes what? So what happens here? So this is 2 over 2 plus square roots of 2 over 2. And this is all over square roots of 2 over 2. So what happens to that 2? Basically goes away, right? So I'm going to end up with 2 plus square roots of 2. And this is all over square roots of 2. We like to rationalize this thing, so we do want to multiply by the square roots of 2 over square roots of 2. And when I do that, I'll have square roots of 2 plus 2 all over a 2. Oh no, hold on. 2 square roots of 2. Whoops, sorry. 2 square roots of 2. And then what happens to my 2? So that ends up being square roots of 2 plus 1. Alrighty. So let's look at number 3. So number 3, so I've got tangent of alpha is going to be 8 over 15. My alpha lies in between pi and 3 pi over 2. So that is a quadrant 3, right? So it lies in quadrant 3. So if I wanted to find sine of alpha over 2. So how do I find where alpha over 2 lies? Where does alpha over 2 lie? So what I'm going to do, I know that alpha lies in quadrant 3, right? So I'm going to divide all of these things by 2. So divide by 2, divide by 2, and divide by 2. So alpha over 2 is going to be in quadrant 2. So quadrant 2, quadrant 2. Okay. Alrighty. So that's super duper important. Alright, so let's go back here and find, if I want to find sine of alpha over 2, I need to know cosine of alpha. Okay. So I know tangent of alpha. So I'm going to go try to down here a little bit. And let's draw a picture. So it ends in quadrant 3. And tangent is going to be 8 over 15. So that is what? So this is what? Negative 8 and negative 15. So they're negative and negative. Yeah. So here's my alpha. So to find cosine of alpha, I do have to use my Pythagorean theorem, right? So negative 8 squared plus negative 15 squared is going to be equal to my hypotenuse squared. So what is that, 17? So cosine of alpha is going to be negative 15 over 17. Sine of alpha, I don't think you need sine of alpha, but just so that we know, it's negative 8 over 17. All right, so sine of alpha over 2. So sine is what in quadrant 2? So sine is positive in quadrant 2. So when I use my half angle formula, so I'm going to say 1 minus cosine of alpha, and then all that divided by 2. And I'm going to use the plus sign out there. So what was cosine? Cosine was a negative, so it'll turn into 15 over 17. And this is all over a 2. So that'll be what? 17 plus a 15. All over what? 34? My math is struggling today. So that's what? Square roots of 32 over 34. And does that reduce any? That reduces to the square roots of 16 over 17. And let's just leave it like that for right now. All right, what about cosine of alpha over 2? In quadrant 2, cosine is what sign? So cosine is going to be negative in that quadrant. Okay, so we're going to choose the negative version when we do this. So it's going to be 1 plus cosine of alpha, and all of that divided by 2. So it'll be negative, then I'll say 1 minus square roots of 15 over 17 divided by 2. So this will be what? 17 minus 15 all over 34. So that'll be square roots of 2 over 34, or just what? Whoops, I'm losing my negative, I'm sorry. Or just a negative 1 over 17. Okay, and I asked you now to find tangent of alpha over 2. So tangent is not positive, sorry, is going to be negative. So tangent is going to be negative here, right? But how I told you, I asked you to find sine of alpha over 2, and I asked you to find cosine of alpha over 2. So tangent is also, remember, the ratio of sine of alpha over 2 divided by cosine of alpha over 2. So why don't we just use those ratios that we already found? So that's what? Square roots of 16 over 17 divided by the negative square roots of 1 over 17. So if I multiply, that turns into what? 17s are going to go away. So it's going to be a negative square roots of 16. And negative square roots of 16 is a negative 4. Okay. Alrighty. So this is your power reducing, your half angle formulas. These are the last of our identities. All right, if you have any questions, let me know.